Okay guys, so let's keep going. Now I'm going to show you something here. The integral of x squared plus 1 squared. Okay? Now 2x dx. You see, this is going to be the inside function, and this is going to be the outside function. Remember? Now, if this is going to be the inside function, you see, you have to do this. U equals x squared plus 1. Alright? So this is the same thing as the integral of u squared, right? But here we go. You cannot do u squared to x dx because there's no more. Well, you're still going to have this dx in here, but what about the u? All right. So you have u squared. Now, if you're going to integrate with respect to u, you need du. Now, what is du? Du, okay, look at this. Du dx equals 2x. That means that, you see what you can do? You can invert these two here, and you can say that dx equals du divided by 2x. Now you have it over here, dx. So this is du divided by 2x, and you have this 2x in here, so you put it in here, and you simplify, and now you have the integral of u squared du. You see that it was very important to have the derivative of the inside function multiplying in here. Right? And now you can do just u cubed divided by 3. And alright? And what is u cubed? It's going to be x squared plus 1. So you can say that this is x squared plus 1 cubed divided by 3, of course the plus c, right? So if you had done like x squared plus 1 squared dx, could you do that? No, you couldn't. All right, you just couldn't, because you were gonna have like look at this. You were gonna have u squared and dx, right? Now how can you relate what is dx? We just found out that it's du, right, divided by 2x. So you put a so you put a du divided by 2x, and now you have to integrate. But okay, but this 2x in here, what are you going to do with it? I mean, you can integrate something in this format, but in this format in here with this 2x in here, it just doesn't work. Okay, so you need, in order to integrate, well, you can do this later when you integrate by parts, but so far we're not going to do that. When you integrate something in an inner function, okay, and you have to also integrate the outer function, you're going to integrate the outer function, but you have to divide by the derivative of the inner function. And since you're going to derive by the derivative of the inner function, the derivative of the inner function has to be already in the formula. So let's do this again, but without substituting. Okay, I'm going to do this in here. Look at that. The integral of x squared plus 1 squared 2x dx. Now, what is the derivative? You have an inner function and you have the outer function. The inner function and the outer function. Okay, so you want to do like x squared plus 1 cubed divided by 3, but then you have to divide by the derivative of the inner function. What is the derivative of the inner function? It's 2x. Do you have 2x in here? Yes, so you can go ahead. Okay, so by inspection, just, you're not going to have to always replace these things in this way. Okay, substitute with other variables and other letters. You don't always have to do that. If you see an inner function, you got to see the multiplying in here. the derivative of this inner function. And if the derivative of the inner function is already here, present in the formula, you know you can go ahead and do it. Okay, so integrating, you're going to get x squared plus 1 cubed divided by 3 divided by the derivative of the inner function, which is 2x. But you already have a 2x in here, so it's done. Okay, because it's going to be 2x divided by 2x, one's going to cut with the other, and hey, you're done. I mean, one's going to cancel the other, and you're done. For example, here, integrate 5 cosine of 5x dx. You see, here you got an inner function and the outer function. What's the derivative of the inner function? It's 5, right? And 5 is here, so you can go ahead and do it. Of course, in this case, you are going to be able to do it anyway, because the derivative of the inner function is a constant. It's not x something, okay? So I'm going to show you guys something. Integrate this. So let's integrate the outer function. It's going to be sine of 5x divided by the derivative of the inner function, which is 5. But you already have a 5 multiplying in here, so you're done. Okay, now let's just say that you did not have this 5 in here. Now let's do it again. Cosine of 5x, integrate that. It's sine of 5x divided by the derivative of the inner function, which is what? 5. So it's this, okay? And you're done. So if you have a 5 in here, you're going to have a 5 in here. These two are going to cancel out, and you have just this. Now, if you don't have this 5 in here, okay, see that? Hold on. If you don't have this 5 in here, so it's going to be cosine of 5x, so sine of 5x divided by the derivative of the inner function and this 5 in here. And since you don't have a 5 to cancel it over here, you're going to have to leave this 5 in here, and you're done. Here we go again. Integrate x squared plus 1 dx. Same thing. Okay. Actually, you got a square here. So you have an outer function and the inner function. What is the derivative of the inner function? It's 2x. You only have an x in here, but don't worry about the 2. As long as you have the x, you got an x in here and you got an x in here, you're fine. All right? So you can go ahead and do it. So, okay, what is this going to be? It's going to be x squared plus 1 cubed divided by 3, all right, divided by the derivative of the inner function, which is 2x. So this is actually going to be 6x. And you got an x in here. You cut this one with this one, you simplify, and you're just left with this. Okay? That's it. Here we go again. Integrate square root of 2x minus 1 dx. What's the derivative of the inner function? This is the inner function. It's just 2. Okay, so you're fine. Don't worry. Now, here's what I'm trying to say something to you. If you were, for example, 2x cubed, now what is the derivative of the inner function? It's 6x squared, okay? You would have to have an x squared in here. All right, that's the difference. But you just have a 2x, the derivative is 2, so that's fine. So let's do this. It's going to be 2x minus 1 to the half, right? So half plus 1, 3.5, divided by the 3.5, which is 2/3, divided by the derivative of the inner function, which is 2. So times 2 in here. So you simplify this 2 with this 2, you're left with this. Okay, it's gonna be the square root 2x minus 1 cubed divided by 3. And of course, every time you have to do the plus c thing, but I'm not gonna do it. I'm just trying to save time. This is a very long course, guys. We're far away. Now, integrate x square root of 2x minus 1 dx. All right. Now, what is the inner function? Is 2x plus minus 1. What's the derivative? It's 2. So if it's just a 2, don't worry about it. What do we do with this x? Well, here it helps if you do some kind of substitution. In this case, it's important to do substitution. Okay, so you know that u, okay, equals 2x minus 1 du. It's du what? You never have something like just one thing, okay? You gotta remember that this du, it's about integration, differentiation is about division. So if you're differentiating something, you're differentiating something else. If you're integrating something, you're integrating something else. So it's never just du, it's du what? It's du dx. But I'm gonna do like du equals 2 dx, okay? Because I could have done du dx equals 2, and then you have to pass this dx over here, but I'm already doing it straight. All right. So if you want, okay, now you have an x in here, and you have to find x, because you see, you can't leave the function like this, x, and now you have to, the square root of u, okay? And since you have a dx, what is dx? Du divided by 2. So you put a du divided by 2, and now you integrate. Hey, you're integrating with respect to du. Okay, what are you going to do with this x? You got to take care of this x. So what is x? Well, isolate in here. Okay, from this, I know that x equals, let's see, it's going to be 1 plus u divided by 2. 1 plus u divided by 2. Okay, so we're going to get this x out of here. I'm going to bring this a little bit more in here. And I know that's going to be, what did I say again? 1 plus u divided by 2. Which is just, how can I say, it's multiplying this thing here. Okay, now you see all this stuff is being multiplied, and you got a 2 times 2 here. Okay, so you can just bring this out. It's going to be 1/4, and then you can make the integration. All right, and what do you have in here? You're going to have 1 u. I'm multiplying this 1 by this square root of u. Okay, so it's going to be u to half plus u to the 3/2, because it's 1 plus 1.5 u to the 3/2. Okay, du. This 2 and this 2 already join them up, and I got the 4 here. So just integrate that, so you have 1/4, and you got to do times, right? And it's u to the 3/2 divided by 3/2, so it's multiplied by 2/3, right? plus u 5 halves 2 fifths. That's what you have. Okay, so let's check this out, guys. You know, I think trying to find the minimum common denominator here. I think it'll be like 60, I don't know. So let's try that. Okay, I don't know if you guys learned this in school. So 2, this one's gonna become a 2. You got a 2, it's a 1. Then you put a 3 and a 5. So it's 15 times 4. Yeah, it's 60. It's a 60. So the whole thing here, okay, gonna become 60. So you're multiplying everything by 1 in here. Yeah, because this 1/4 is multiplying this, right? So, oh yeah, actually it's not a 60. I'm sorry. This thing is just it's 15. Okay, it's 15 because this is multiplying. You're just adding here. So this is going to be 1/4 times, and then you put a 15 here. So it's going to be 15 divided by 3, 5 times 2, 10. U 3 plus 15 divided by 5, 3 times 2, 6. U to the 5 seconds. This is u to the 3 seconds, right? Because there, and then you have to multiply in here, which is going to be a 60. So you get this thing out of here, and you put a 60 here. And now you can simplify it by 6. So you make this disappear. You make the 60 disappear, and it becomes a 10. And oh no, yeah, you can't divide that by 6. You gotta divide it by 2. Yeah, just 2. Okay, so this becomes a 3. This becomes a 30, right? And this one becomes a 5. Yeah. That's it. And if it's not it, guys, I think that's it. Oh yeah, and I'm not back. I forgot to back substitute. Okay, so yeah, you have to back substitute. All right. So you have what? 5, right? Times u. What is u? 2x minus 1. So it'll be 2x minus 1 to the 3 halves. Okay? Plus 3. And you got 2x minus 1 to the 3 halves to the 5 halves. Let me see here. All of this divided by 30. Okay, yeah. All right. Yeah, you can see that these things are becoming very complicated, eh? You see that it was important to have a substitution there. You had to use the u because otherwise it was gonna get too crazy. The integral of sine squared of 3x times the cosine of 3x dx. This one you're not going to have to use back substitution because you see this is the outer formula, okay, and this is the inner formula, and here you got an even inner formula. Now what is the derivative of this? It's just 3, so don't worry. What is the derivative of this? It's cosine, and I do have the cosine in here, so I have what I need, remember? So let's do this. Let's integrate this. It's going to be sine cubed of 3x divided by 3. Okay, now I integrated the outer function, the outermost function. Now you gotta go like one level down. You gotta divide by the derivative of the function inner to this function here, immediately inner to this outside, to this outermost function. What is the differential, the derivative of sine? It's the cosine, right? Sine of 3x, I got a cosine of 3x here, and the cosine of 3x is here, so I'm fine. Because you see, guys, it's going to be the cosine of 3x, right? Which this one is this one, but then you also have to divide by the derivative of the inner function. Not this inner function here, but this inner function here. You have 3 levels. The outermost function, the innermost function, and the middle function. Okay, so I integrated the outermost function, then I go to the function inner to the outermost function, which is the middle function, which is the sine, and I got to divide the whole thing by the derivative of that. What is the derivative of sine of 3x? Cosine of 3x. I have it in here, so I can just put cosine of 3x. Okay, and now I got to divide by the derivative of the innermost function, which is what? 3. So dividing it by 3, I got 3 in here. This one's going to cut with this one, and I'm left with sine cubed of 3x divided by 9 plus c. Let's do some more exercises. And if you guys think that this is complicated, wait until you get to integration by parts. It'll be a pain. Okay? What is the derivative of the inner function? 3. Since it's a 3, it doesn't matter if I have a 3 here or not, but whatever. So it'll be 3x minus 1 to the fifth, right? Dividing by 5, dividing by the derivative of the inner function, which is 3. But then you have a 3 multiplying in here, you're fine, it's over. Another exercise, integral of 2x plus 1. You got x squared plus x dx. All right. Now, you don't have an inner function and an outer function. As a matter of fact, you do. You do have an inner function and an outer function. This is the inner function, and this is the outer function with the 1 hidden in here. Okay? Now, how do I know that this is not the inner function? Because by inspection, okay, what's the derivative of this? It's 2. What's the derivative of this stuff in here? It's 2x plus 1. Hey, guess what? I have 2x plus 1 here. I have 2x plus 1 here. Okay, so actually, I'm going to integrate this stuff. So, here we go. X squared plus x squared divided by 2. All right, divided by the derivative of the inner function. The derivative of the inner function is 2x plus 1. So, yes, technically I would have to write 2x plus 1 here, all right? But I have a 2x plus 1 here in the denominator, so repeating it, 2x plus 1, you're just going to cancel these two, and you're left with x squared plus x squared divided by 2 plus c. Yeah. The integral of 3x squared square root of x cubed minus 2 dx. What is the integral, the differentiation of the inner function, 3x squared. I got 3x squared here. So don't worry. All I gotta do is x cubed minus 2. It's to the half, so it's to the 3 halves. Divided by 3 halves, it's multiplied by 2/3. Divided by 3x squared. But I got 3x squared here, so you're just gonna cancel them out and I'm fine. The integral of minus 4x divided by 1 minus 2x squared dx. What's the derivative of the inner function? Minus 4x. I got a minus 4x in here. So, you see, this is going to be, this is to the, okay, let's just do it. It's this to the minus 2, right? Because it's in the denominator. So if it's squared, it's actually up here in the numerator to the power of minus 2. So let's do that. So you're going to do 1 minus 2x squared to the power of minus 1, because minus 2 plus 1, minus 1, divided by minus 1. So you put a negative here. Okay. So that's it. Divided by the derivative of the inner function, which is minus 4x. But you also have a minus 4x in here multiplying, okay? It's not like this, guys, minus 4x, no. It's actually multiplying, okay? So you have to do this. Okay, so this minus 4x divides by this minus 4x and you're left with minus 1 minus 2x squared. This is the answer, plus c. Okay, last one for this video. Cosine squared of x, sine of x, dx. So the inner function is the cosine, the outer function is 2. What is the derivative of the cosine? It's the minus sign. That's fine because you have a sign in here. Okay, don't worry about it. So it'll be cosine cubed of x, okay, divided by the minus sign. And in here you have multiplying sign of x. Okay, so this one's going to cut with this one, but since everything is positive here, and oh yeah, and you got to divide it by 3, right? Because it's cosine cubed divided by 3. So since everything is positive in the numerator and in the denominator, you got a negative, the whole thing is just going to become a negative, okay? So it's going to be equals minus cosine cubed of x divided by 3 plus c. Yeah, because in the numerator everything's positive in it, and in the denominator there's a negative here. So guys, I think that'll be it for this one. I'm going to show just one more thing to you guys. In the denominator, in the numerator. Now we're going to make a definite integral that goes from 0 to 1, right? X, and here you have an x squared plus 1 cubed dx. Now, the inner function is x squared plus 1, so you can just divide by the derivative of that, which is 2x, and you got an x in here, so you're fine, you can go ahead. You could do this straight, but I'm going to do it with u substitution because I want to show something to you guys that when you substitute, you also have to replace the limits, okay? So let's just say that u equals x squared plus 1. du equals 2x dx. All right? Okay. Now, here we go. There's something that I want to show to you guys. And what is x? Because you got an x in here. So what is x? Yeah, x is going to be very complicated. Because it's going to be x is going to be I just want to see here. Okay. Well, you don't have to worry about this x. You don't have to worry about this x. You had to worry about it before isolating the x in here in this function, okay? Because this x in here was here, and inside you had some, instead of like x squared plus 1, you had something like 2x plus 1. So the derivative was just going to be 2, and you had an x in here, okay? Which is, this doesn't match. There's no x in here, but there's an x in here. It's complicated, so... but this time, what is the derivative of this? It's 2x, so you do have an x in the derivative of the inner function, and you have an x in here, so you're fine. You don't have to isolate the x. This x in here, you don't have to isolate it here. If you did, it was going to get complicated because you would have to like x equals plus or minus the square root of u minus 1, all right? It was going to get nasty. Okay, so, all right, dx, you see, dx equals du divided by 2x, all right? So this equals, now here we go. You got an x here. This is u cubed, okay? And you're going to put a du. But what is dx? It's actually du divided by 2x. So we got du divided by 2x. This x in here is going to cancel out with this x in here, so they're gone. All right? But here's the thing. Now you're integrating with respect to du. Okay? Not with x. The limits of x were 0 and 1. Now what is the limit of u? So you have to substitute in here in this formula. So when x is 0, u is going to be 1. So you put a 1 in here. When x is 1, u is going to be 2. So you put a 2 in here. Now you can integrate. This 2 right here, I'm going to get it out of here. And I'm going to multiply it outside. All right? So it's half of u to the 4th divided by 4. These things are multiplying, right? And okay, with a 1 and a 2, okay, so let's see, it's going to be u to the 4th over 8, and you still have to replace these things, okay, so what's going to be, u is going to be 2, right, so this thing is going to be equal to 2 to the 4th, that's 16. 16 over 8. Okay, I could have just divided this, but I'm already thinking ahead of time because I know I'm going to have to put this in fraction form again, because look at this, minus, and you have this 1, so 1 to the 4th divided by 8, it will be 1/8. Okay, now 6 eighths minus 1/8. Yeah, 6 eighths minus 1/8. You're going to have 15 eighths. All right, that is the result. So we got 15/8. I just want to see if we were going to get the same thing. I'm going to put this here. If we had done it straight, I actually don't know. I think we're supposed to get the same stuff. Okay, let's try this again. This is going to be equal to x squared plus 1 to the fourth over to the fourth divided by 2x, but you got an x in here, so the x will disappear, and 2 is going to multiply with this 4, so it's going to become an 8. Okay, so let's do this again. When it's 1, you're going to have 1 squared 1 plus 1, 2 to the fourth, 16 divided by 8, 16 divided by 8 minus. When x is 0, this is going to be 0, so you have 1 to the fourth, 1 divided by 8, and voila. We get the same result, 15/8, 15/8. Guys, that'll be it for now.